Judges. This is Aditya from Team Slayers. Let me start with the fact that 17% of the global CO2 emissions come from industrial chemical processes. The bottleneck isn't ambition, it's catalysis discovery. Right now, finding the right catalyst for a reaction takes 3 to 5 years and costs millions. We built Catalysis OS to compress that to hours. This is Catalysis OS. It is a reaction-aware AI-native catalyst discovery platform specifically for green chemistry teams. You are looking at a live dashboard for ethanol-to-jet fuel program. This isn't a chemistry wrapper around a chatbot. This is a full multi-agent orchestration pipeline backed by generative AI, graph neural networks prediction, and multi-objective ranking. Let me take you to what and how it works. So let's launch a discovery. So first of all, we can select a particular reaction that for which we are supposed to find what the catalyst can be, or we can generate some catalyst. So let's go for CO2 plus methanol, or yeah, we can go for ethanol to jet range hydrocarbons. We can select any kind of temperature or pressure and H2 feed ratio. Right now, let's keep it as it is, and we can launch a discovery. Boom! There are four AI agents named as Nagarjuna, Kanad, Vagbhat, and Somdeva. They are named after ancient Indian chemists out there because this is AI for Bharat. And Nagarjuna, what it does is it retrieves the existing databases and finds out what are the best available catalysts right now under the known conditions. Then Kanad generates different possibilities using AI, and it finds out what can be the new catalyst and what can be the new configuration of that. Then Vagbhata finds out the risk scores based on activity, stability, and several other parameters. Then Somdeva analyzes the historical literature and literature research based on what are being generated outcomes, and it maps it and identify whether it is good or not and gives out a parameter. These are the discovery logs, what are done by each and every agent. Then these four agents find out, and right now we have found out 23 candidates ranked, 15 were known, and 8 are AI generated. And these are those candidates. Then we have visualization plots for them. This is the first scatter plot for those particular identified catalyst mechanisms. Then we have ranking. Yeah, so first is being ranked RU carbon K5. And these are the top 6 ranked catalysts that can be used for this particular reaction at these conditions, right? Then we have a molecule-based diagram that is very important for the green chemists to understand and identify how these chemicals will react in the particular surface, right? Because the surface chemistry and physical chemistry is a lot of involved in this. So this visualizations will help a lot to the green chemists. This is there for all the possible outcomes that we have already suggested over here. Yeah, so these were the parts that are being suggested, and this can be exported as a protocol. This is a downloadable file, and this can be downloaded and viewed as a TXT file over here. Yeah, this can be now this what these predictions are given. These predictions will go to the laboratories, and those laboratory experiments will be recorded over here. Like suppose if this kind of catalyst is being given to us, and this is given to the laboratory, then its actual yield, selectivity, and stability, temperature, everything is being recorded. And once it is recorded, we can just simply find out the prediction versus reality, like what we had predicted and what was the actual situation. And according to that, we can just retrain the model based on the new data that we are feeding it, and it increases the accuracy as it gets retrained. Then we have metabolic pathways for the biology pathways basically.